This video covers margin convention. The structure of this video is as follows. SVG viewport revisited. D3 group element revisited. D3 margin convention. Line chart case study and the summary. Alright, let's get started. SVG viewport revisited. Things within the SVG viewport's dimensions are visible. Things inside the SVG tags, though outside the viewport dimensions, are not visible. Things inside the SVG tags, though outside the viewport dimensions, still exist. They are just not visible. SVG coordinate space works in the same way that mathematical graph coordinate space works, except for two important features. 1. SVG coordinate space has its origin point 0, 0 at the top left. 2. SVG coordinate space has the y-coordinates growing from top to bottom, which means when we are given the coordinates of 25, 25, we go 25 units from the left to the right, and we go 25 units from the top to the bottom. The width and height that we choose for the SVG coordinate space are completely under our control. We can make it as big or as small as we want. There are two ways to think about how to choose the dimensions of the SVG viewport. 1 is to let the data tell you how big to make it. 2 is to choose hard numbers and to scale the data up or down accordingly. Way number 2 is the preferred way to choose the dimensions of the SVG viewport. Looking at this data visualization, you can see that the text on the screen ran out of room in the viewport. This made the text partially hidden. One way to fix this issue is to add margins to the graphics in case there is a runover, which means that we make the SVG viewport and then we make a smaller internal drawing container where everything will be drawn. The margins specify the space between the original SVG container and where the smaller internal drawing container lives. We can define the margins all at once as part of a JavaScript object. For the inner drawing container, we can group everything inside of it in an SVG group element. D3 group element revisited. The SVG group element is used to group SVG elements together. You can think of the SVG group as a container. The G tag is the SVG group element. Anything inside of the G tag is considered to be inside / part of the G container. There are two main reasons to use the SVG group element. 1. To group a set of SVG elements that share the same attributes. 2. To define a new coordinate system for a set of SVG elements by applying a transformation to each coordinate specified in this set of SVG elements. When you use a group element, it can be for one reason or the other, or both. With a group element, you can apply a set of transformations. These transformations will transform every element inside of the G group. The transformations do not affect elements outside of the specific G group to which the transformation was applied to. What the G element transform is doing is transforming the SVG coordinate space. The translate functionality can be thought of as moving the 0, 0 point of the blue coordinate system to a 0, 0 point in the purple coordinate system. So everything inside of the G element is now operating inside of the purple coordinate space. So by defining an SVG viewport and then defining a group element with a transform, we have defined a new coordinate space that we can treat as a regular coordinate space. The margins we define then separate the sides, the top, and the bottom of the group coordinate space from the SVG viewport container. The margins we define then separate the sides, top, and bottom of the group coordinate space from the SVG viewport coordinate space. Everything we then draw can be drawn only in this new coordinate space. By using the G element, we can assume away the margins and only focus on this new coordinate space. D3 margin convention. This is the margin convention commonly used in D3 examples, particularly in the D3.js.org website. This is a JavaScript object. It is not a JSON object because it does not have double quotes around the keys. Though the margin number values may differ slightly between examples, the JavaScript object structure is the same. Because margin is a JavaScript object, we can use the keys to access the values inside. This lends to a very readable variable that details all of the margin information. The margin top, margin.right, margin.bottom, and margin.left tell you specifically that you are looking at the margin and which type of margin. Just because you can encode and compress your JavaScript doesn't mean you should. The two JavaScript statements on the screen are equivalent and do the exact same thing. Imagine 6 months from now trying to decipher what the top version does versus the second version. So make sure to create and name variables in a way that makes it very easy to read and understand later. There is a concept in computer science called self-documenting code. While this is not quite there, it is close enough that just by reading it out loud, we can get really close to the meaning. The width is equal to 960 minus margin.left minus margin.right. Makes sense, and the only question we would have left is the width of what is equal to that equation. Let's take a look at an example from the D3.js.org website example section in order to see the margin object in action. Line chart case study. We are going to look at the line chart on the D3.js.org website. We navigate to the example section of the website and scroll down to the basic charts section. We click on the line chart. You can now see the line chart. If we scroll down the page, you can see the code that has created this line chart. First comes the CSS formatting, then comes the actual D3 code. Finally comes the data used to construct this chart. Going back to the top, let's look at the graph. We can see the y-axis on the left side of the screen. We can see the x-axis at the bottom of the chart, and we can see the line chart of the data in the middle of the screen. At the bottom right of the chart, there is a link called Open in a New Window. This link takes us to a new window where the only thing on the HTML document page is the chart and the code created to generate it. Let's click on that link. This opened up a new tab for me. You can't see that it is a new tab for me because I'm zoomed into the browser, though know that it is. It will be a new tab for you if/when you click on the link yourself. Now we open the developer tools. A few things to notice. First, the D3 script link is located inside of the body instead of the head of the document. Second, the script that defines the chart using D3 comes after that. Third, the SVG is defined after the script. As you'll see in a second, this is because the SVG was appended to the body element, so it was added as the last child element. Okay, so we see how the file is defined and structured. Let's go back to the first tab to take a look at the code. We scroll down the page to get the script that generates the chart. The first thing we see is the margin declaration. This is the JavaScript margin object. This was covered earlier in this video. Next is the definition of the width and height of what will eventually become the chart. This will be used to define the interior SVG coordinate space. Now that we have the width and height and the margins, let's go down the code a bit to see where they are used. This is where the margin variables and the width and height come into play. Let's go back to the screen to see what we can make of this statement. Here we have the variable declaration as well as the SVG declaration. We will go step by step to make sure we understand what is happening in this code. We have already covered the variable declarations. The first line we look at this time is the green highlighted line. This line is declaring a variable called SVG. What is being assigned to it is a D3 selection containing the SVG element that has been appended to the body element. This is straightforward and something we have seen before. Next, we define the width of the SVG element by adding the width attribute and its value. We have seen the width attribute before. What is new here is how the value of the width attribute is being constructed. The width variable is having the margin.left and the margin.right added back into it. Since the variable declaration subtracted them out earlier through some mental arithmetic, we can see that the width of the SVG will be 960. Next, we define the height of the SVG element by adding the height attribute and its value. We have seen the height attribute before. What is new here is how the value of the height attribute is being constructed. The height variable is having the margin.top and the margin.bottom added back into it. Since the variable declaration subtracted them out earlier through some mental arithmetic, we can see that the height of the SVG will be 500. So far, so good. We have defined the SVG viewport container. It is 960 pixels wide by 500 pixels tall on the HTML document screen. But we don't stop there. We then append an SVG group element. The SVG group element is added to the SVG container we just defined. The G element is what everything else in this D3 chart is appended to, even the x-axis and y-axis. The last thing we do is add in a transform attribute to the SVG group element. The value of this transform attribute is a translate operation. The translate operation will move the origin point of the G group element margin.left units to the right and margin.top units down. The G element taken in with the transform/translate operation will act as a new coordinate space for the graph to be drawn in. And with that, we have used the D3 margin convention to set up a new coordinate space in an SVG container to draw a graph in. The margins will provide more than enough space for the x-axis and y-axis to fit in. This new coordinate space also serves as the de facto coordinate space for drawing the chart. The summary. This video covered SVG viewport revisited, D3 group element revisited, D3 margin convention, line chart case study, and the summary.